We're going to look at a problem involving the combination of two solutions of ionic compounds. In the original solutions, the ions are dissociated, and in the final combined solution, we need to consider what products might form by looking at different combinations of the ions. In order to determine the identity of the precipitate, you can consult solubility rules. Remember that the precipitate is labeled with an S to indicate that it is a solid. As you consider what's going on in this reaction, you need to make sure you balance the equation, and then you need to look at the given amounts to determine the limiting reactant. In this example, we will calculate the moles of each reactant and compare the mole ratio we have available to the mole ratio that's needed as given by the coefficient. In this problem, the silver nitrate is limiting because we just don't have enough of it to react with all of the calcium chloride. In order to determine the grams of the precipitate, use the limiting reactant and the mole ratio to do the stoichiometry. Before we can calculate the final concentration of every ion, we need to revisit the scenario and recognize that two things will change the concentrations of the ions: the dilution that occurs when the two solutions are poured together, and the chemical reaction in which ions are removed from solution and put into the precipitate. Of the ions found in the precipitate, the one coming from the limiting reactant will have a final concentration of 0, but that's not the case with the other ion because some will be left in solution and some will be in the precipitate. For each of the spectator ions, you simply need to figure out the final concentration of the ion based on the original concentration and the dilution that occurs. In each case, determine the moles of the ion from the original solution and divide that by the final volume of the mixed solutions in order to get the molarity of the ion. For the ion in which some of it is in the precipitate and some of it is left in solution, find the original moles of the ion in the solution, subtract the moles that went into the precipitate in order to get the moles remaining in solution, and calculate the concentration from that. In review, the silver ion coming from the limiting reactant ends with a final concentration of 0 because all of it is in the precipitate. The chloride ion, on the other hand, ends with some of it in the precipitate and some remaining in solution. The spectator ions, in this case calcium and nitrate, are aqueous as both reactants and products. The moles of each ion doesn't change, but the volume does, thus changing the molarity. As you can see with this kind of a problem, it's important to keep track of everything and pay attention to the scenario. If you do that, you should find great success.